So we have these 6 people, u, v, w, x, y and z, and there are 12 intersections marked for us, but no one is standing at intersection D, so I'm going to strike that off first. Nobody is there. Now I think the good important starting clues are 1, 2 and 4. 1 says x, u, z are standing in the 3 corners of a triangle formed by 3 street segments. Triangle formed by 3 street segments is either here or here. So x, u, z together are taking either BGF or BGC. This much can be confirmed from clue 1. Clue number 2 is more important. It says x can see only u and z, the other two vertices of that triangle, and everybody else is standing in intersections that cannot be seen by x. And the fourth clue says u sees v standing in the intersection behind z. So u, z, v is in a straight line, which is important because it basically means that u, z cannot be in the slanting line. They have to be either horizontal, something like uzv, or vertical, something like uzv. And uz along with x will make a triangle. So based on this, we can draw an exhaustive list of cases, and that is what I recommend doing, because it is guaranteed to give you a solution if you apply proof by contradiction properly. So I'm going to take copies of this to draw all the cases required. You want to look at it this way: uzv horizontal. Let's see how many cases there first. uzv horizontal could be there, or it could be below uzv. 2 horizontal cases. Now let's look at the vertical cases. uz is not possible because that will force v onto intersection D, which is not allowed for anyone. So you can have uzv, one vertical case in the leftmost column. You can have uzv in the middle column. You can have in the opposite direction uzv. There are 3 vertical cases, 2 horizontal cases, for a total of 5 cases. If you can do all 5 cases, you are guaranteed of the answer, and the sooner you contradict, the better for you. So let's take the 5 cases and see how it goes. 1, 2, 3, 4, 5. So I'm going to take the horizontal cases here. You know what, I'll write the horizontal cases here. uzv, which will automatically put my x here. The other horizontal case is uzv, which puts my x here. The vertical cases uzv puts my x here, uzv puts my x here, uzv puts my x here. Let's see how quickly we can contradict these cases. Now x can see only u and z, so you can't have anybody here, 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 here. Y can see only u and w. W cannot see v or z. Now in this case, if w cannot see v or z, w cannot be in this column or this column, which only leaves us with w here. Now that was clue 5, and clue 3 says 6 has already been used. 3 says y can see only u and w. Where can you place y says that y can see only u and w? There is no such solution, so this case has been contradicted. Now let's go to this case. uzv horizontal, x is at B. Now x can see only u and z, so that means there's no one at A. or F or J. W cannot see V or Z, so W cannot be in the second or third columns. W can only be in the first column. The problem is there is no other intersection left in the first column. So this case has been contradicted. Now let's look at the top left one. UZV X. Now X can see only U and Z, nobody else. So you can strike off H, K, F, E. W cannot see V or Z, so it cannot be at I or J. W can only be at L. And it is given Y can see only U and W. Where can you put Y says that Y can see U and W? There is no space like that, so contradicted. You have this case in the middle. At the top, X at B, U, Z, V at intersections G, F and E. Let's see what happens. X can see only U and Z, nobody else, so strike off intersections C, A and J. W cannot see V or Z, so W is not at I, it is either at W cannot see V or Z, it is not at I, it is not at H, can only be at K or L. W is either at K or L. And what about Y? Y can see only U and W. You want to put Y at a place where it can see U and W, but only U and W. So you can put I think you can put Y here and W here. Let's check all of the conditions again. X, U, Z in a triangle. X can see only U and Z, cannot see the others. Y can see only U and W. True. U sees, that's already done. W cannot see V or Z. W cannot see V or Z. This seems to be the correct case. We'll look at the next one as well. X cannot see anybody else, so strike off C, A and J. W cannot see V or Z, so W cannot be at K or L or E. W is forced onto I, which is the only intersection left. And Y can see only U and W. There is no space where you can place Y, such that Y can see U and W, but nobody else. So this is also wrong. So I think this is the correct case. We will just check the answers to the questions as well. So let's look at the questions. The first question is, who is standing at intersection A? There is no one standing at intersection A. The answer is no one. Who can V see? V can see Z and U only. Z and U only. What is the minimum number of street segments that X must cross to reach Y? X can go from B to G and from G to K, 2 segments. Last question, should a new person stand at intersection D, who among the 6 would she see? If we have a person at D, who can they see? They can see X, they can see W. W and X only. So we have 16 shells, 1 to 16, and 12 items A to L. There are 5 types of biscuits, 3 types of candies, and 4 types of savories. Only 1 item in each shelf, placed clustered together without a gap. There's at least 1 empty shelf and at most 2 empty shelves between 2 two types of items. And let's look at the clues. K is placed in shelf number 16. K is here. Let's go in the order in which we can use them. D, E, F are savories and are placed in consecutively numbered shelves in increasing order after all biscuits and candies. So savories happen after biscuits and candies, but we don't know whether biscuit is before candies or vice versa. But savory is the last category, and D, E, F are three of the four savories in increasing order. And so the last one, K, is also a savory. This is one block that we have. Four savories. That is clues 3 and 4. I'm just going to move this. We also have C is a candy and is placed in a shelf preceded by two empty shelves. Candy is a block of 3. C is preceded by two empty shelves, so C is the first of the 3 candies. Two empty shelves before that, and two more varieties of candy immediately after C. We don't know which ones they are, we don't know the order. Biscuits is a set of 5. Savories is a set of 4. We have already identified them. D, E, F, K. There has to be at least one gap before. Notice that there are 12 items in 16 shelves, so there are exactly 4 gaps. As soon as they tell us that the set of candies is preceded by 2 gaps, we can conclude that biscuits are preceded by exactly one empty shelf, savories by exactly one empty shelf. It has to be. But we still don't know whether biscuits are before candy or candies are before biscuits. That we don't know. Now, we have used 6. L is to be placed in a shelf preceded by exactly one empty shelf, means L is the first of any one block. And the first of the candy block and the first of the savories block is already gone, so L has to be here and is preceded by exactly one empty shelf. L is a biscuit. L and J are of the same type, so J is here, and H is of a different type. Savories are all gone, so H is here. I'm gonna move this further. Okay. Now we know that I and J are to be placed in consecutively numbered shelves, so they are of the same type. Both higher numbered than the shelves in which A and B are kept. They're both higher than A and B, but between them who is higher we don't know. And that leaves us with only G is left as the last spot. Now, so basically L is followed by AB and AB is followed by JI. Now regarding clue 1, which is the only thing we have not used, A and B are consecutively numbered in increasing order, so it's A followed by B, and then JI in some order that we don't know. It could either be JI or IJ. Now the same thing is true for the HG. There's no other information that will help us sequence it. It's either HG or GH. There are 2 possibilities. There is also the issue of, is biscuits first or candies first? That gives us 2 options. We can have, there has to be exactly one empty shelf here. We can have L, A, B, J bar I with one empty before and 2 empties before C and H bar G. This is one possibility. The other possibility is to have one empty L, A, B, J I, 2 empty shelves C, H bar G. The rest is same even in the second case. D, E, F, K. So these are the two possibilities as far as the sequence of the kinds of items is concerned. We have case 1, candy followed by biscuit followed by savories. Case 2, biscuits followed by candies followed by savories. But even within these cases, there are sub cases because we don't know the order of HG, we don't know the order of JI. So that is basically what we can find from the set data. Now we have to solve the sub questions based on the extra information in the sub questions. Let's look at it. The first question was, in how many different ways can the items be arranged in the shelves? So there are already two arrangements with respect to which classes of items are going to be in which order. You can either have CBS as shown above or BCS as shown below. So there are two ways of doing that, and within the set of candies there are two ways of arranging H and G, and within the set of biscuits there are two ways of arranging J and I. So that gives you 2 into 2 into 2 is equal to 8 total arrangements possible. The second question is, which of the following items is not a biscuit? We have L, A, B, J, I. L is a biscuit, A is a biscuit, B is a biscuit, G is not a biscuit. Answer is G. Third question, which of the following can represent the numbers of the empty shelves? So we have two options, 1, 2, 6 and 12, which is already there, and the other option is 1, 7, 8 and 12, which is not there. So the other options are wrong. 1, 2, 6, 12 is the answer. Last question, which of the following statements is necessarily true? There are at least 4 shelves between B and C. We have to look at this for all the possible cases. For it to be necessarily true, it has to be true for all 8 arrangements. So we'll be trying to disprove the wrong ones. Now option 1 says there are at least 4 shelves between B and C. In the above, C is at 3 and B is at 9. So there are at least 1, 2, 3, 4. There are 5 between C and B in the upper arrangement. In the lower arrangement, B is at 4 and C is at 9. There's 5, 6, 7, 8 between. There are at least 4. And it doesn't matter how you rearrange H and G, doesn't matter how you rearrange J and I, there is at least 4. So this is already true. You could technically stop here, but you can also disprove the other ones if you want. There are 2 empty shelves between biscuits and candies, which is not true here. Here it is true. So that one is false. The third claim is all candies are kept before biscuits. Fourth claim is all biscuits are kept before candies, and both of them are disproved by taking the opposite case. So it's not C or D. So it's not option 3 or option 4. Option 1 is the right answer. So the main para tells us that no dancer performed their second item before the performance of first item of any of the other dancers. So slots 1 to 4 everybody danced once, and slots 5 to 8 everybody danced the second time. Also the dancers performed the second items in the same sequence as the performance of the first items. So the same sequence that is in 1 to 4 is repeated in the same order in 5 to 8. Now let's look at the clues. So the clues that you cannot use immediately, don't waste your time with them, move on to the other ones. 1 and 2 not immediately useful, go to the third one. The first performance was by Princess. First is by Princess, and so will the fifth. This item was assigned by Badal. That's talking about the first one, so composer is Badal. Clue 4 is saying last performance is by Rani. Last is Rani, and so will be the fourth. This item was assigned by Gagan. Last was assigned by Gagan. 5. The items assigned by Ashman were performed successfully. This is only possible in the fourth and fifth. The first stage of items 1 to 4 and the second stage of items 5 to 8. Their boundary with slots 4 and 5 is the only place that you can have a person assigning two consecutive items. Now, the number of performances between items assigned by each of the remaining composers was the same. So we have A, outside of A you have two B's, two G's and two D's. The differences are the same. Now, you can eliminate all the other options. You cannot have the difference being 1, because that will lead to a contradiction in the case of D. If you try to put difference equal to 2, it doesn't work out for D. So you have to jump across to the other side. So these two cases anyway do not need to be checked, because they will do once in 1 to 4 and once in 5 to 8. So as far as B is concerned, B is either going to be 7 or 6, and I will first disprove 7. If B is 1 and 7 with a difference of 6, G should be 2 and 8 with a difference of 6, and then D will be 3 and 6 with a difference of 3. That's a contradiction. So we are only left with one more possibility, which is B is 1 and 6 with a difference of 5, G is 3 and 8 with a difference of 5, and D is 2 and 7 with a difference of 5. They all have the same differences. So we have used 3, 4 and 5. Now we can go back to 1 and 2. 1 says no composer who assigned item to princess. That would be B and A assigned to queen. B and A did not work with queen, so queen cannot be here. Queen has to be here, and so queen will have to be here as well. And you have Samrajni here and here, 2 and 6. Now you can compare with the second option as well. It says it's basically redundant at this point. No composer who assigned to Rani, which would be A and G, worked with S. A and G did not work with S, as you can see. S worked with only D and B. So that is the solution. There is a unique solution to this arrangement, and now we can look at the questions. Let's look at the questions. First one is, which of the following is true? Third by Ashman is false because it's G. Third by Dew is false. Second by Gagan is false. Second by Dew is true. So that option is true. Next question, which of the following is false? Queen did not perform with in an item composed by Gagan. She did. So that is false. So that is the false option there. Let's look at the other ones. S did not perform with Ashman, which is true. Rani did not perform with Badal. Rani did not perform with Badal is true. And Princess did not perform with Dew is also true, because she performed with B and A. They were asking for which one is false, so the answer is option 1. Next question is, sixth performance is composed by whom? That will be Badal. And the last question, which pair of performances were composed by the same composer? It's 1 and 6, 2 and 7 and so on. First and the sixth is the correct option from the given options. So the rules are such that the number of extra rounds that you play in 4, 5, 6, the bonus rounds, depends on the number of bullseyes that you have in rounds 1, 2, 3. So even before looking at the numbered clues, the first things that we can determine are that Tansy had in the unknown round 1 and round 3, she had a 5 and one more number, which is not a 5, because she got one bonus round. Umeza had 2 5s and some other number. Wangdu did not have a single 5. Zyla played all 6 rounds, which means first 3 were all 5s, which we can put inside directly. Yonita had 1 5 and another non-5 number. Zeneca had 2 5s and a non-5 number. So yes, that's the first step. Second, let's read the number clues. Total scores for all players except one were multiples of 3. This is very important. 5 of the 6 people had multiples of 3 as the final score, and the 6th person did not. First clue says Tanzi, Umeza and Yonita had the same score. So clearly this same score should have been a multiple of 3. They are all at 3x. Now the highest score is one more than double of the lowest score. Now we don't know for sure who is the highest scorer here. Could be Zyla or Seneca from the looks of things. But let's look at Zyla's score. Zyla already has 21 points from 5 of the rounds. Her score, she has a score in the 6th round which is unknown to us. So Zyla is greater than 21. Now either Zyla is the top scorer or Zeneca, and we'll look at it. If the highest scorer is one more than double the lowest score, so highest is an odd number. One more than double will be an odd number. So if you assume Zyla is the highest, then Zyla has to be an odd number, so it could be 23, which is possible by putting a 2 here, or 25 by putting a 4 here. You can't have 27, that would require a 6, not possible. So it's either a 2 or a 4 with a sum becoming either 23 or 25. But notice that highest is one more than double the lowest, which would make the lowest 11 and 12 respectively. Now the problem with the 23/11 case is that these are both numbers which are not divisible by 3. So now you have two numbers not divisible by 3, so you'll reject this case. This is possible, 25/12 is possible. The other thing that you need to consider is, what if Zyla is not the topper? Then Zeneca would be the topper. Zeneca would have to beat Zyla's score, whatever that is. So if you assume that Zeneca is the highest, there are a few cases that we can see. First of all, Zeneca cannot be 25 because that would require 5 5 5, in which case why is she not being allowed to play in the 6th round? So that's a contradiction for the assumption that Zeneca can hit 25. So that can be chucked. Zeneca cannot be 23 and be the highest because of the same situation with 23/11. And if Zeneca is 21, the next high odd number, then Zeneca is already below Zyla. So we see that any case that we try to assume Zeneca is the highest and we get a contradiction immediately. So Zeneca is not the highest, Zyla is the highest, and that high score is actually a 25, with somebody getting a low score of 12. So we can put Zyla's sum as 25, which would be 5 5 5 5 1 4, and the lowest is 12. Now before we proceed with putting the 12 for a person, we can find out the value of this 3x. Think about it. Look at Tanzi's score. There is a 5 and a 4, and the unknown round 1 and round 3 contains a 5 and another number, which is a non-5 number. The three known numbers currently add up to 14. So the last number should either be a 1 or a 4, so that you can have a multiple of 3 in the end. Now out of these two, one of these cases can be rejected. If you put a 4, if you assume a 4, you will get a total sum of uh, 18, and if you assume a 1, you'll get a total sum of 15. Now take the 18 case. If Tanzi is 18, Umeza also has to be 18, and Umeza's 18 would require 555, which would give you a contradiction because then Umeza should be playing the 6th round as well. That's a contradiction, and that came from the assumption that Tanzi's sum was 18, which came from the assumption that Tanzi's final score was 4, which is wrong. This 4 is wrong, so we'll reject it and we'll stick with the 1. So Tanzi has 5154 in some order with a sum of 15, and so does Umeza, and so does Yonita. They're all at 15. Zenaka we know is about 20, so the person with the lowest 12 has to be Wangdu. And for Wangdu to get a 12 and not have any of the bonus rounds, Wangdu should have done 444. That is the only possibility. So we fixed Wangdu entirely. Umeza's 15 contains 2 5s, a 2, and a 1 2. Wangdu's has been fixed completely. I am not going to bother with this. Zyla complete. Yonita has a sum of 15 as well, which requires a 5 and a 2 along with the 5 and the 3 that's already in the table. That gives you a sum of 15. Now Zenaka should have a multiple of 3. So the last one is either a 1 or a 4, giving you a sum of either 21 or 24. We don't know which. Now let us quickly look at what we have used. Clue number 1, Tanzi, Umeza, Yonita have the same total score we have used. We found all of them to be 15. Total scores are all multiples of 3 used. Highest score is 1 more than double the lowest used. These are the two things that we have not used. Bullseye in round 2 was double that in round 3. Now that means that you can have either 1 bullseye in round 3 and 2 in round 2, or you can have 2 in round 3 and 4 in round 2. You can't have more than 4 in round 2 because you already have two people who failed to hit the bullseye. Now you want to disprove one of the case and then fix the other. So if I take there is only 1 bullseye in round 3 and only 2 in round 2, let's see where this goes. That means this remaining 5-1 would have been in this order, 5-1. The 5-5-2 would have been a 2 here and the 5-5 here, and the 5-5 unknown, which I'll take it as 5-5 would have been an A here and a 5-5 here, because I'm trying not to get any more 5s here. There's already a 5 here. I want a total count of only 1. And when I tried to do that, what happened was there are now 3 5s in round 2, which is already a contradiction. So this case is wrong. So then I'll backtrack for a bit and I'll go for the other case, which is that there are 2 5s in round 3, 2 bullseyes in round 3, 4 bullseyes in round 2. That will give me all of the others are 5s. What else can we write at this point? We have written this 5, so the last one should be a 2. So that part is done. We have written one of the 5s, so there's a 5-2 left in the second row. Now we have also written a 5 for Zenaka, so we have a 5 and a 1/4 left in the 6th row. Now we come to the 5th clue, which says Tanzi and Zenaka have the same score in round 1 but different scores in round 3. Tanzi has a 5 and a 1 left to place. Zenaka has a 5 and a 1 or a 5 and a 4 left to place. If we choose 5-1 for Zenaka, then either both round 1 and round 3 will match, or neither will match. And both of these situations are contradicting what is given, which is that round 1 will match but round 3 score will not match. So we have to reject 5-1 as an option for Seneca, and we have to choose 5-4, at which point for round 1 to be the same we'll have to put 5-5, and for round 3 to be different we'll have to put 1-4. Now Seneca has a total of 24. That is also fixed. Now to get the second bullseye in round 3, I will have to put my second 5 here, which will mean that I'll have to put a 2 here, at which point I have all the values that I need, and this is satisfying all of the given conditions in the question. At this point you can just directly solve the sub questions that follow. Let's look at the questions. The first question was, what is the highest total score? We have already found it as 25. 25 is the answer. What is Seneca's total score? We found it to be 24. Which of the following statements is true? Zyla was the highest. We know this to be true. Seneca was the highest is false. Seneca's score is 23 is false. Zyla's 23 is false. What was Tunzi's score in round 3? Tunzi in round 3 scored 1 point, and those are your answers. So we are given data about the top 10 states in terms of the number of crimes happening, and it is classified according to IPC crimes, SLL crimes, and other crimes. So we are given 9 of the top 10, and it is stated that the other one in the top 10 is West Bengal, where all 520 crimes were 520 cases were SLL crimes. So the total is 520 and the split is 0, 520, 0. That is the information that's given to us. And we're given a partial table with ranks of these states for each category of crime. Some ranks are blanked out and we don't have that information. The first question is, what is the rank of Kerala in IPC crimes? If you look at Kerala, you'll see that Telangana and Puducherry are below, Haryana is below, Maharashtra is above, so is Karnataka, and they're both at 3. Now, so Karnataka and Maharashtra have equal values in terms of number of IPC crimes. Goa is higher than them. Delhi is much higher than Goa as well. So if they are both at 3, Goa should be at 2 and Delhi should be at 1. Now we have 3 third ranks, which means 4th rank will be skipped. Kerala can get rank 5, and that is basically the answer. The second question is, in the 2 states where the highest total number of cases were registered, what is the ratio of IPC to SLL? So those 2 states would be Delhi and West Bengal. Delhi has a total of 140 something. I'm guessing 143 maybe. And West Bengal we know is 520, of which all are SLLs. So the IPC by SLL ratio will be Delhi's IPC is around 63. West Bengal is not contributing anything. Delhi's SLL is maybe 90 up to 98 maybe. That will be 35. And SSL, West Bengal's SLL we know for sure is 520. We get a ratio around 63 by 555. The actual value doesn't matter. We have very widely spaced options. We can eliminate very easily. It is out of the options, it cannot be any of the first 3. It is very close to 1 by 9. That is the answer. Third question, which of the following is definitely true about the ranks of states UTs in the other crimes category? The other crimes category is the last one. Delhi is around let's say 44 maybe. and Karnataka has mid-20s. That's all we know, right? Mid-20s. Goa has less than 20. Tamil Nadu has more than 30, mid-30s basically. I'm just going to take it as a rough value of 35. Maharashtra is very low. The other one that we need to compare is Puducherry. Puducherry has around 30. Kerala is low, it is around 10. Haryana around 5 6. Telangana around 5 6. Maharashtra around 5 6. I don't know the exact values, doesn't matter. These are all lower. We have Delhi at the top, then Tamil Nadu, and then Puducherry. That will give you Delhi is rank 1, Tamil Nadu is rank 2, and Puducherry is rank 3. So both their claims are correct. Both 1 and 2 is the answer. Last question, what is the sum of ranks of Delhi in the 3 categories? We have found 2 categories already. First is 1, last is 1. We need to find the middle one. SL crimes we found to be around 60, around 35 for Delhi. I'll use a different color. 35 for Delhi. Karnataka has more than that. I'm gonna put a high arrow. Goa has nope. Kannada is ranked 2. Oh, we're talking about SLL, where West Bengal is 520. So the only person above Karnataka is your West Bengal. That's for sure. Now, Goa is low 30s. Maharashtra is low 30s. Haryana is less than 30. So I think Delhi's 35 is higher than that. Delhi should get a rank immediately below Karnataka, which is 3. And then you'll get the other numbers. Goa and Maharashtra are given as 4. So we know that they're both below Delhi. Maharashtra is 4th, Goa is also 4th. Delhi should be 3rd in the rank. And so the sum of the ranks is 1 plus 3 plus 1, which will give us 5. 5 is the answer. So we have been given data in a web chart. I have tabulated it, taken all the data on a table. It is not necessary to tabulate it to solve some of these questions, but it makes it very easy to do the explanation. And once you have tabulated it, you don't really need the graph at all. We can work with the table. So let's look at the questions. The first question is asking which of the aspects has the lowest median. So if you have 5 values, the median will be the 3rd value in either the ascending or the descending order. So we can just look at that. For reliability, it's 75, 60, and 52. For reach, it's 80, 70, 65. For quality is 70, 68, 62. For features, it's 90, 75, 55. For customer service, it's 70, 55, 50. And for cost, it's 90, 80, 75. The lowest median is the 50 for customer service. So customer service is the answer. Let's look at the second question. The second question is asking vendor's final score is the average of their score in all the 6 aspects. Which vendor has the highest final score? Who has the highest average? Clearly everybody's average is 1/6 of their sum, so the highest average will correspond to the highest sum. So we just need to find the sums and see who is the highest of the sums. Now before we go further, I just want to point out that these values may be wrong by a little bit. The 62 might be a 63 or a 61. I don't know about that because it is not, you can see from the graph that you can't read it accurately, but it doesn't matter because none of the questions ask you to find a specific value. They're all asking you to compare as opposed to calculate. So minor differences don't matter as long as they're very close and as long as the order is right, which is true for most of the questions here. So anyways, they're asking for the sums. The sums are 372, 333, 397, 340 and 341, at least according to the values that I've taken down from the graph. But the difference is pretty big. 397 is clearly much bigger than the others. So vendor 3 will have the highest sum and therefore the highest average as well. Third question, list of all vendors who are among the top 2 scorers on the maximum number of aspects. For each aspect we have to find the top 2 scorers. So it's 75 and 60, 80 and 70, 70 and 68, 90 and 75, 70 and 55, 90 and 80. So you'll notice that vendor 1 has 3 aspects, vendor 2, 3, 4 have 2 aspects each, and vendor 5 also has 3 aspects. The highest number is for vendor 1 and vendor 5. Last question, list of all vendors who are among the top 3 vendors in all 6 aspects. Top 3 as opposed to top 2, so we'll take the next value for each, next highest value for each row. So 75, 60 and 52 is also added. 80, 70, 65 is there. 70, 68, 62 is there. 90, 75, 55 is added. 70, 55, 50 is added. And 90, 80, 75 gets added. So you'll see that there is only one column that is completely circled. Vendor 3 is in the top 3 in all 6 aspects. The answer is vendor 3. So in this set we have a certain number of variables that changes according to the question we are solving, but A has a value of 1. There's exactly one diamond ring. B can have a value greater than or equal to twice of A. It has to be at least double of A, but it could be more than that. It cannot be less than that. And the same thing goes for the subsequent variables. C has to be at least twice of B, but could be more than that. D has to be at least twice of E, of C, and so on. But the sum of these variables should be exactly 100. We also have A plus B plus up till whatever level you are taking should add up to 100. That is basically all of the data in this question, all of the relevant data. And then using this we have to solve each question with the additional instructions that are giving in those sub questions. So the first of these questions is asking you what is the minimum number of different types of prices that you can have, minimum number of variables essentially. Remember the fact that the first variable has been fixed at 1, the second variable has to be minimum 2, but there is no upper limit specified. So you can just put B is equal to 99. There are 99 prices of type B, and that would take you to your 100. So the answer to the first sub question, the minimum possible number of types of prices is 2. The second one is the maximum possible number of prices, number of types of prices, and for that you have to look at the smallest possible values you can have for each variable. So that is A is equal to 1, B is equal to 2, C is equal to 4, D is equal to 8, 16, 32. You know that this is a GP of common ratio 2, where the sum is 1 less than the last term at every point, or you can say it is basically 1 less than the next term in that GP. So up to here the sum is 3, up to here the sum is 7, 15, 31, 63, and so on. So if you add one more term here, the sum will be 127, which will exceed 100. So we can conclude that you cannot have 7. 7 is not possible. And if you remove that 64, the sum at this point is 63, but this is the minimum. You can always replace 32 with a bigger number. You need another 37 to make this 100. Just replace 32 with a number that exceeds 32 by 37. And so your sequence is basically 1, 2. It's just one of many ways of doing this, but I'm just demonstrating that 6 is possible after demonstrating that 7 is not possible. 1, 2, 4, 8, 16, and 69. Notice that this adds up to 85, 93, 97, 100. So the answer to the second sub question is 6 types maximum. The third question is asking which of these cases is not possible. So we have to demonstrate through example which ones are possible, and whatever is left is the one that is not possible. So the first option is 30 items of type B. Now this is possible, and I can demonstrate it by just putting a 1, a 30. This is a sum of 31, so we need 69 more, and I can just put C is equal to 69. Notice that the conditions that they have given us have been satisfied. 30 is more than double of 1, 69 is more than double of 30. So option 1 is possible. So it is not the option that is not possible. Second option is saying 60 of type D. To have 60 of type D, I can put 60, 30, 9, 1. Notice that it adds up to 100. Each term is more than double, or at least double, of the previous term. So second option is possible. Third option is the answer, so we'll come back to that. Fourth option is saying exactly 75 items of type E. So the fifth one, 75. So you want the other 4 to be 25. You can just put 1, 2, 4, 8 and see that it adds up to 15, and then replace the 8 with an 18, and you can see that the conditions are satisfied and the sum is 100. So 75 of type E is possible, which means that the answer is 45 of type C. Now if you want to look at that in detail, if you put 45 of type C, it is not possible to reach 100 without using D, because the best you can have is 1, 22, 45. This is going to be definitely less than 100, but if you use a fourth variable, whatever you do, the lowest you can do is 1 to 45, and the smallest you can have with 4 variables is definitely greater than 100. The biggest you can have with 3 variables is definitely less than 100, so you cannot have equal to 100 at all with C is equal to 45. So it is the answer. The fourth question is basically telling us that as far as box 45 is concerned, there is a particular price in it, and the same price is present in 31 boxes, 31 of the 44 boxes to its left, and in 43 of the 55 boxes to its right. So that's basically 75 boxes containing the same type of present. That is basically the only information in this question. 75 items of the same type are present in this particular case. Nothing much to read into the box numbers given, because there is no particular order in which the prices are placed in the boxes. So the question basically translates to this: given that there are 75 prices of the same type, exactly 75 of the same type, what could be the maximum possible number of types? Now 75 is gonna come after smallest, a few numbers smaller than it. You have to look at how many numbers can you fit into the section before 75, because you definitely don't have a number after 75, because if it were present it would be at least 150, which is not possible. So the thing is, before that 75 there are a bunch of numbers that add up to 25. The question is, what is the uh, maximum number of terms that you can put there, remembering that each term is at least twice of the previous term. So let's just go the smallest possibilities. 1 2 adds up to 3, add a 4 it adds up to 7, add an 8 it adds up to 15, add a 16 it adds up to 31. So you can't have the 16. If you have 5 terms, the minimum sum is 31, so you can't have that. You can have 4 terms, the minimum sum is 15. We need 25, which you can achieve by just increasing the last one by 10. So we can have this 1 2 4 18 75 situation that works out perfectly for us. It gives us 5 different types possible, but 6 different types is not possible. So what we have is the answer to 4 is basically 1 2 4 18 75, and the number of types maximum is 5. So in this puzzle we have to find the values corresponding to the 10 variables A, B, C, D, E, F, G, H, J, K. They correspond to the digits 0 to 9, but we don't know in what order. So we have to find out which digit corresponds to which letter. Now, and this is a legitimate addition that happens in your regular decimal system. Before we proceed, it's crucial that you understand the role of the carry and how it will affect your calculations. So for example, without going into the question, let's just say if I have an A and an F and I have 5 here, it doesn't directly mean that A plus F is equal to 5. There are many other possibilities. If there is an output carry, that's A plus F is adding up to 15 is also a possibility, which would mean that there is a carry in the next place. That's an output carry. Now it could also be that there is an input carry, so there was a carry after the previous place's addition was done, and that would mean that 1 plus A plus F is 4. Now if you have both input and output carry, then that means that 1 plus A plus F is 1 plus A plus F is equal to 5, or A plus F is 4. And if you have input as well as output carry, then 1 plus A plus F is equal to 15 and A plus F is equal to 14. So just remember that it is possible that if you see this, then A plus F could be either 4 or 5 or 14 or 15. That many possibilities are there. So don't just assume as soon as you see something like this that A plus F is equal to 4. There are other possible values. It's crucial that we understand this before we go ahead with this puzzle. Now we'll try to find whatever we can find easily. This actually the set is structured in a way that you can solve the first 2 questions very quickly. Now 2 6-digit numbers are being added and the sum is a 7-digit number. Whenever this happens, whenever the sum is one more digit, that most significant digit has to be 1, and this is pretty easily explained. I have a 6-digit number here, which means a number less than 1 million. The second number is also less than 1 million. So the sum has to be less than 2 million. So either it will have 6 digits or it will have 7 digits, in which case that 7th digit, most significant digit, has to be 1 because the sum is less than 2 million. So That is the first step for us. The A is a 1, so all A's are 1s. Now we got that 1 through an output carry. So what is the value of B? B plus A with or without a carry should have added to 11 for us to get the output carry, and that basically means that B has to be 9, the biggest possible. It still is only 9 plus 1 is 10. How can we get to 11? Because there was an input carry as well. Now at this stage we are already done with the first two questions, so if you can't proceed, the least you should do with this set is to quickly get the first two questions. So we have one was A and 9 was B. That's what I found, and these are the answers to the first two questions. Now what else can we find? At the rightmost or the least significant digit there is no input carry, so it is f plus f is equal to f. This is only possible for f equal to 0. 0 plus 0 is equal to 0. So f is 0. Also there is no output carry because 0 plus 0 is not 10, it is just 0. So there is no output carry. Now so that means g plus k is either 1 or 11, but g plus k cannot be 1. So g plus k is actually 11, and the 1 was here, and the and units place 1 is here, and then other one will go as an output carry. So we don't know the value of g and k at this point, but their sum is 11. So I'll just note it down. G plus k is equal to 11. Let's just keep it on the side. Now in the hundreds place we have an input carry of 1, A is also 1, and then you have f and c. F has already been found to be 0, so C will be 2. C will be the letter whose value is 2, and there is no output carry. So now you have 0 plus 1 plus j is equal to g. J plus 1 is equal to g, which means that in this table g will be to the immediate right of j. We don't know where there is, but we'll keep that information on the side. Now we also have h plus h is equal to f. We know that f is 0. So how do you get h plus h is equal to f? It cannot be that the sum is 0. The sum can be 10, and so that means there is no carry. So one thing that I didn't already mention is that when you're adding two numbers, if a carry is present, then that carry has to be 1, or the carry will not be present. You cannot have a carry of 2 when you're adding just two numbers. You'll need to add at least 3 numbers to get that. So anyways, 2 h's and a possible carry adding up to an even number means that there is no carry, because 2h is always even and the sum was also even, so carry was not there. And how do you get to 0? It is actually 10 with an output carry, so h would then be 5. H should be 5. 5 plus 5 without a carry will be 10. So you get a 0 here and a carry in the next position. So this is what we have found. H is 5. Now we are still left with a few more things. You have 5 blanks, of which we have to figure out the positions of G, K and J, and D and D on the other hand are 2 letters that are not there in the summation. So let's look at the possibilities. J and G are adjacent, so that's a good place to start. G is 1 more than J, so you can put a J here and a G here and see what happens. J3, G4 will give you K7, because G plus K should be 11, and 6 and 8 we don't know, they belong to D and D in some order. That is one case. Now you cannot put JG here or JG here because H is in the place. So the next case that you can try out is J equal to 6 and G is equal to 7. If G is equal to 7, then K will be equal to 4 for our sum of 11, and the remaining spots are 3 and 8. D and D will take them in some order. You can also have JG as 7 and 8 respectively. If G is 8, K is going to be 3 for a sum of 11, and 4 is going to be left behind, so 6, 4 and 6 will be taken by D and D in any order. So these are the three possible solutions. We don't have sufficient information to get to a unique solution, and when you have insufficient information, you get more than one solution. So we have three solutions here, and based on this we can solve the third and fourth question. Let's look back at the questions. The first question was the value of A. So the first question, the answer was 1. The second question was the value of B. The answer is 9. The third question is asking out of 3, 4, 6, 7, which cannot be the value of D. Out of 3, 4, 6, 7, you'll see that 7, in all three cases 7 has been taken by the letters which are part of the addition. So D cannot be 7. D not equal to 7. So 7 is the answer basically, because the question is asking what value D cannot take. Answer is 7. The fourth question, which among 4, 6, 7, 8 cannot be taken by G? Now as far as G is concerned, G can either be 4 or 7 or 8. It cannot be 6. So the answer is 6.